Hello, this is Mrs. Schroeder. We are going to talk about section 9.2 now, talking about limiting reactants and percent yield. Today, we're going to cover the following objectives. We're going to look at what a limiting reactant is, which we've talked about already, but more importantly, using that to calculate theoretical yield. How much can you make of something? We're going to look at something called percent yield today. So limiting reactant, we've already talked about this with our S'mores lab. Limiting reactant is a substance that controls how much product you can form. It's usually used up by completely in the reaction. The excess reactant is not completely used up. It would be left over when the reaction is complete. Often we use the less expensive reactant in excess. Obviously you're trying to save money. You want to make sure the more expensive one is completely used up. Sometimes chemists look at which one is more toxic, and that's the one they'll use up first. The less toxic one would be in excess. So just a quick review of limiting factors. If I have the following bike frames and I have some wheels, I want to see how many bikes I can build. What's my limiting factor? So I'm going to go ahead and build my bikes here. And you can see with my 6 tires, or my 6 wheels, I can build 3 bikes. Even though I have 5 frames, I can't build 5 bikes. So I can only build 3 bikes. Limiting factor would be the frames. And we do the same thing with chemical reactions. So we're going to use our chemical terms here. Theoretical yield. If a reaction happens perfectly, theoretical yield is the most that can be made. So when I was looking at the bikes, my theoretical yield for bikes would be 3. I could make 3 bikes. It's always based on limiting reactant though. Let's say one of the wheels got bent when I was trying to put it on. It messed it up. Now I can only make 2 bikes. So my actual yield might be different. But theoretical yield is how much could we make. First thing to do to calculate limiting reactants. There really aren't any shortcuts. You can't look at the numbers and know automatically. You have to figure out how much product could be made from either reactant. Basically, you have to do 2 stoichiometry problems. Again, there's no shortcuts. Compare the amount made to figure out which is the limiting reactant. Whichever one has the least amount is the limiting. The theoretical yield then is the lower amount of product. Again, the frame said I could make 5 bikes. The wheel said I could make 3. My theoretical yield is only 3. It's the one that makes the least amount. And we've talked about s'mores already. So here's the example we're going to try. If I have hydrogen sulfide gas, it is formed when HCl reacts with FeS. Iron chloride is the other product. If I have 130 grams of my iron sulfide mixed with 70.4 grams of hydrochloric acid in a solution, I want to figure out the limiting reactant and the theoretical yield of the H2S. Again, there really are no shortcuts. I can't do anything to just look at those numbers and tell. I have to do 2 full stoichiometry problems, which means I have to go from my mass to moles, go from moles of my FeS to moles of H2S, and then figure out how many grams of that I would need in order to figure that out. So I'm going to go ahead and try doing this. If I have 130.5 grams of FeS, and I'm going to draw my lines. When I take the molar mass of FeS, I find 87.91 grams for every mole of FeS. Next, I'm going to go to the one that I want. I want to go to H2S. And I'm going from 1 FeS. Again, the numbers in front come from the coefficients in this. There's nothing there, that means it's a 1. And finally, I go to the molar mass of H2S, which is 34.08 grams for every mole. When I calculate that out, I come up with 50.59 grams of H2S for my finished product. That's the first one. Again, I have to do this a second time. It only works if you do these twice. Okay, the other one I have is my 70.4 grams of HCl. Again, I'm going to do a stoichiometry problem with this one. I'm going to find out how much H2S I would make if I was starting with just that much H2O, or HCl. So for every the molar mass of HCl is 36.461 grams per mole. In this case, there is 2 in front of my, so 1 H2S for every 2 HCl, and my molar mass of H2S I already calculated up here, so I just come down here, 34.08 grams per mole for H2S. And when I figured that out, found out that I would make 32.90 grams of H2S. So I've calculated this number twice, and now I need to answer the question that it was asking me about. Determine the limiting reactant. Which is the limiting reactant? Well, which one made less? 32.9 is less than 50. So my theoretical yield is this. And my limiting reactant then would be the HCl that I'm starting with. My Fe2S is called the excess. And that's all you have to do. 2 stoichiometry problems, compare the answers, and then state at the end how much you have. We'll do some practice problems in class tomorrow. Equations tell us what should happen, but not all reactions are perfect. Again, some reactions don't go to completion. Some will actually reverse once they start getting so far. Sometimes reactions are lost through vaporization, crystallization. Sometimes side reactions occur. So we have 2 things we use called actual yield and percent yield. Again, it's some new vocabulary terms. Actual yield tells us how much is actually produced. It's always less than theoretical. Okay, when you're figuring these out, think about that. You can't make more than you can possibly make. So actual is always less than theoretical. Percent yield is a convenient way to describe the reaction. How efficient is it? A reaction that's a 90% yield is much more efficient. It means it makes more product than one that's only 50% efficient. That has a lot of waste to it. So when I do this, again, I'm going to calculate percent yield is going to equal the actual, and my messaging is kind of writing here, over the theoretical. Okay, so I'm going to do this. Percent yield is going to equal my 41.9 grams is the actual. I'm going to divide that by my theoretical. When I did my stoichiometry, it said I should make 50 grams, and that's going to equal, of course, times 100 to get to percentage, 83.8% would be the percent yield. So percent yield is 83. The actual yield was 41. Okay? And the theoretical yield comes down here is 50. And we'll do some more practice problems in class to make sure we go through those, how to do those. Make sure you go back through this video, write down your examples. Do not just write down the vocabulary, write down the examples so you can see how to do these.